Okay, now we're going to talk about weighted graphs, the Chinese Postman problem with two odd vertices. We'll talk about four odd vertices a little later. And to begin with, we're going to talk about Eulerian circuits and semi-Eulerian circuits. So here is my notes that I got from listening to Pablo on the IB vodcast clicking on this link. You must click on this link to get these notes and the explanation. I'm not going to explain that for you. And once again, that link gives you notes on this. You can check with the way it's written with how I've written it. Or you may want to highlight your paper in the same way that I've highlighted mine. So this is my paper. You can hit pause if you want. Okay. Pablo mentions that the Chinese Postman problem is also called the Czech snowplow problem because they want to efficiently go over each edge once without having any repeats. So if you click on this link here, Pablo explains this whole process. I've colored it nicely to kind of help explain. Okay, so now I'm going to do the problems which IB Vodcasting doesn't do. Okay, slightly different problem. In this case, we're going to begin and end at A, and we want to find the total weight. So the very first thing I do is, if you look at what our what we want to do is we want to identify the two odd vertices and then find the shortest path. Okay, so when I look at the vertices, I can see that that's got 4, this is 2. Oh, so the degree of B, it looks like it equals 3, right? 1 path, 2 path, 3 path. And the degree, 1, 2, 3, 4, 1, 2, the degree of E also has 3. So on my notes there, I've been denoting a blue dot with things that have an odd degree. Okay, that was my designation of having an odd degree. So, so we're going to begin by finding the two odd vertices. Okay, so here's a little helpful notes. Okay, so by the intersections, find the least weighted route between these two vertices. So between B and E, the least weighted route, I would say, is from here to here, right? Because 8 plus 6 is 14, 7 plus 4 is 11. So the least weighted route, shortest path, is from E to C to B. E to C to B, which is 7 plus 4, which equals 11. So this is my shortest path. I've been highlighting my short paths in pink. So this is the path that we're going to have to repeat. Okay. So, but they want us to start with A. Okay. In the other example that Pablo gave, we started and ended at the blue dots. So this is slightly different, but okay, we're going to start with A. So, so basically, I'm going to try to find a path that gets me through the whole thing, and then I have to go back. I'm going to have to go back. I'm going to have to go back this way, and I'm going to have to go back this way. Okay, and then I'll do this path um, only once. So if I'm starting at A, what color should I use to start with A? I don't know. Okay, I'll just make a big circle. Okay, I'm starting with A. So if I'm starting with A, I'm going to go, and I'm going to do this part at the very end. So I'm going to go A to F to B, down this way, back this way, down this way, back this way, back this way, back this way. Okay, and now I can do my repeat paths, which is this guy, and then I finally end up back here. Okay, so let's just, what did I just do? I went from A to F to B, down to C, over to F, over to E, over to C, down to D, over to E, and now I'm doing the duplicate path from E to C, and from C to B, and then now to A. So I like highlighting my duplicate path, the E to C and the C to B. There's my path that's getting repeat, the repeat path. Okay, so now we need to find the total weight of this route. Okay, so first of all, I'm going to find the total weight of everything. So I'm going to add everything we've got. So we've got 4 plus 5 plus 6 plus 4 plus 5 plus 8 plus 7 plus 4 plus 5. So adding all of these together once gives me 48. This is the total of all of the paths. So the total weight is going to be equal our total of 48 plus our extra path of 11. And if you add those together, your total path is going to have a weight of 59. Okay. Okay. So we went from A to F to C to this way, this way, this way, this way, this way, this way, and then I did the pink graph, and then I went this way. Okay, so all the orange paths add up to 48. So these paths that I've highlighted in orange add up to 48, and my extra path, which is the duplicate, is 11. Okay, I hope that helps clarify anything you might have had with Pablo's question. So first thing I need to figure out the two odd degrees. So degree of A is odd, it's 3, and the degree of D is odd, it's 3. Okay, so so the shortest extra path I can't spell. The shortest extra path between A and D is just between A and D is 2. Okay. So, all right. So, do we need to start at any particular place? No. So I'm just going to start at Okay, let's just start at A. So if I'm starting at A, I can go A to B, to C, to D, to E, back to A. Wait. Okay, and then I'm going to go from A to D, and then pink D back to A. So what did I just do? I did A to B, to C, to D, to E, to A, then to D, and then back to A. Okay, so my duplicate repeat is this here. There are different ways to do the whole thing. So you don't necessarily need to have it quite in this order. There's other ways you could have done. I could have gone A, B, C, D, A, E, D, back to A. There's a whole bunch of different ways to do this. Anyways, so all of the orange routes, if I add them together, we've got 3 plus 2 plus 2 plus 1 plus 1 plus 2. If I add all of those together, all of the orange ones, that adds up to 11. So my total weight is equal to 11 plus my duplicate extra short path, which is 2. And so my total weight is going to be 13. Okay. I hope this extra examples helps you with what Pablo was explaining. I thought he explained it really, really good. So, okay, here is my work that I figured out. C and E had the odd paths, and the shortest path between C and E was 12, E to F to C. And then I added them all together, we got 91. And so the total weight is 91 plus the extra short path of 12 gives me our total weight. And here is one of the possible ways. I don't know why they wanted you to start at A, but that makes it a little trickier, but it's still doable. I think it's easier to start from the blue point, but what do I know? Okay. Odd is A, and an odd degree is F. And so the shortest way between F and A is F to B to A. Okay. That's F to B to A is my shortest path. Okay. When I went through this, I chose I could go from A to B to F to E to D to F, and then duplicated the FB, and then to D, then to C, then to B, and then I duplicated the A. Okay, add it all together. We got 285, and then added our extra short path. There's our total weight. Okay, the odd degrees was G and E. And the shortest path between G and E is this path, the 16 plus the 14. Our shortest repeated path is GFE, which is 30. And but it says if he takes the short path a second time, it only takes 1/3 of the time. So this weight of the 30 gets divided by 3 since it only takes 1/3 of the time. Maybe hit pause and rewind and hear that again. So this extra short path is 30, and since it only takes 1/3 of the time to walk it, he's going to divide that part by 3. Okay, so Find the minimum length of time it could take for the postman to complete the route, including the part that he's going to walk twice. So we add all the paths together, we get 160, and the part that he's going to walk past a second time, but 1/3 of the speed, or take 1/3 of the time. Add those together as our total weight. Okay, question II. Okay, if the postman has to walk down both sides of the street on either side of the sidewalk, explain why he never has to walk down any street more than once. So if he has to walk down both sides of the sidewalk, that means we're multiplying every edge by 2. It could be shown that there's 2 edges between every point. So that's going to make the degrees even for between every single point. So it's going to become a Eulerian circuit. There we go. Okay, question 3. Okay, this represents bus routes. Tourist staying at a town wishes to travel along all the routes and return to A as cheaply as possible. Find the minimum possible cost point. So I went through the process here, and we found out that G and E both have degrees of 3. And the shortest route between G and E is, well, from here to here is 5 and 6, which is 11. Or I could take the pink route, which is 4 plus 5, which gives me 9. The pink route is the shortest route. Okay, so if I add up all these points together, add them all together, I did it right here, the sum of all the points is going to be 50. And then we add our additional repeat route of 9, and so there's our minimum cost here. Okay, a new bus route is added between G and E. A new bus route is added. So if I'm adding a new bus route between G and E, I've drawn it here in green, and this journey costs $7. So I'm going to put a little 7 there. Okay, so now it's going to become a Eulerian circuit, because now I don't have to do any repeat thing. So if I'm not doing a repeat thing, we're just going to have our 50. We're just going to have our 50 plus the 7 but we don't have to do the repeat route of 9, and so we're going to have our minimum cost. The new minimum cost is going to be 57, because I don't have to repeat the short path of 9, and but I do have to add the new pathway of 7. And I hope that helps.